So in this video, we're going to learn how to solve quadratic equations by factoring. And we did a factoring video where we did, the AC method. So we'll do the same thing here. And what we're going to do is we're going to factor both, we're going to factor the trinomial into two factors. And so what we're going to do is, again, I have a whole video on factoring trinomials. So in this video, we're going to assume that we know how to factor trinomials, okay, and know the basics behind it. So here we go. We want to go ahead and factor this trinomial. So we look at the A term, the C term, okay, this is your A term, and then this is your C term. So the C term is 10, so when we find all the factors of 10, we got 1 and 10 and 2 and 5. We need the combo that gives me 7 in the middle. Well, it's going to be 2 and 5. All right? And what we do is we write down the first term, write down the last term, choose the 2 and 5. We're going to call that 2x and 5x because that's the variable we're using. And we can see in order to get a plus 7, these two numbers have to be plus as well. It's the only way to get a plus 7. And then we're going to do what we call factor by grouping. We're going to take out the GCF on the left side, which is going to be x. And then x plus 2 is left behind. On the right side, it's going to be a plus 5. Okay, let me write it in red. That's the GCF. Because the leading coefficient of the 5x is plus, so the plus 5 needs to be factored out. Then we're just left with x plus 2 equals 0. You notice that the x plus 2 is identical, so that's going to be one of my factors. That's actually my GCF of the trinomial. And then the x plus 5, we're just going to write that in its own parentheses. Okay? And don't forget this is still equaling 0. And then we use the zero product property, where if the product of these two factors equals 0, then you can set them individually to 0. And we can solve for x for each equation individually. So minus 2 here gives you x equals minus 2. That's going to be one of my solutions, right? And here I'm going to subtract 5. And then it's going to be x equals minus 5 as my other solution. Okay? So we just have to be able to factor when we do these, right? Okay? So let's do a next one here. Okay, so again, the A coefficient is 2, and your C coefficient is 6. So 2 times 6 is 12, and we want to find all the factors of 12. Well, 1 and 12, 2 and 6, and 3 and 4. So the combination I'm interested in is what gives me 7 in the middle, and that's going to be 3 and 4 without a doubt. So I'm going to write down my first term, write down my last term, leave some space, and write 3x and 4x in the middle because that's the variable I'm working with. Again, they both have to be plus in order for me to get 7x in the middle. Then what I do is I do factor by grouping by splitting them down the middle. I take out the GCF of x on the left side because x is the smallest exponent, same variable, choose the one with the smallest exponent, that's the GCF. And then now I just have 2x plus 3 that's left behind. And of course my GCF on the right side is a plus 2. And then I'm going to get 2x plus 3 on the right side as well. Okay, so 2x plus 3 is one of my factors, and then the x plus 2 comes from the GCF of x and 2 that I pulled out before. Set these to 0. The zero product properties, I can use that, and then set both of them to 0. And I'm going to have to solve for x individually for each equation, but that should be pretty easy. This one here, all I got to do is subtract 2. Then I get x equals minus 2. So I already have the solution, one of the solutions there. Here I'm going to move the 3 to both sides. And then I have 2x equals a minus 3. And then divide everything by 2. And I'm going to get x equals minus 3 over 2. And that would be the solution for the other one. So essentially, when I'm solving for these solutions, I'm actually finding the intercepts, right? If I graph this, this graph is going to intercept the x-axis at negative 3.5 or negative 3 halves, and then at negative 2. All right? Okay, so, okay, let's go ahead and do this example. And what we want to do is we want to find a GCF between 27, 54, and 27. And if you come to realize that 27 is actually the GCF of all three of those numbers, because 27 goes into 54 2 times, so that reduces to 2y. This is 1. All right, so when I take out the GCF, I have y squared plus 2y plus 1. So if I distribute that back, I'll get my original polynomial back. Okay? And if you're struggling with the GCF, remember the method that I showed you? You can start dividing these by a number, and it looks like I'm going to pick, like 3 would work, right? Let's say I pick 3. 3 into 27 is going to be what? 9, right? And then, of course, 54 divided by 3 is going to be 18. 27 divided by 3 is 9. Again, I can pick 3 again. 3 goes into 9 3 times, right? 18 3 goes into 18 6 times, right? And then of course this goes into it 3 times again. And then I just keep picking on 3. 3 would work. 3 goes into 3 once. 3 goes into 6 twice. 3 goes into 3 once. Now we don't have to get every column down to 1. All right, so what we're going to do is we're going to stop and then multiply these numbers together, and you will get 3 times 3 is 9, times 3 is 27, and that equals the GCF. So you can always apply that method that I showed you before to get the GCF if you're struggling with it. All right, now this is going to be a very easy polynomial to break down. You notice the C coefficient is 1, so 1 times 1 is the only possibility you're going to get. Okay, so we have to choose that combination. All right, so go ahead and rewrite it here. Write down your first term, write down your last term, and we're going to pick 1 and 1, so we'll call that 1y and 1y, because that's the variable we have. The only way to get a 2y in the middle is they have to both be plus. Do factor by grouping. The GCF on the left side. Okay, don't forget this 27 kind of stays the same. Okay, kind of its own entity. All right, so just bring that down. Okay, the GCF on the left side of y squared plus y is just going to be y. And then in the parentheses, we're going to have y plus 1, right? And in here, to the right, the leading coefficient is plus 1, so that needs to be factored out. Then, of course, you're going to have y plus 1 again. Notice that these are identical. So your two factors are y plus 1. And then here's your y plus 1 in red. And then the 27 that we factored out earlier, just throw that out front. That doesn't change anything yet. Don't forget this is still equal to 0. And then we're going to set all the factors to 0. Now, 27 does not equal 0, so don't worry about that. Okay? Y plus 1 equals 0. Y plus 1 equals 0. If we subtract 1 on both sides, we're going to get the answer y equals minus 1. And we don't need to write it twice, okay? So just, like in other words, when you solve this equation, you're going to get minus 1. The answer can only be one of these because it's redundant. And then, of course, we ignore the 27. Does not equal 0 because that's false. So forget about that. So the solution is just y equals negative 1. Okay? All right. I have another example I want to show you. Okay? And here, this is the difference of two perfect squares. You remember that? So this is the difference of two perfect squares. So we can just go ahead and fill in the parentheses. So 81x squared, remember, is 9x times 9x. 36 is 6 times 6. One has to be plus, one has to be minus, okay? Because you have to get the minus 36. Okay? Then we set both of these to 0. And start solving, okay? So if I subtract 6 on this side, I get 9x equals minus 6. Add 6 to this side, I get 9x equals 6. Okay? Then I'm going to divide both sides by 9. And that's going to give me x equals a negative 6 over 9, which reduces to negative 2/3 if I divide both numbers by 3. Because we want to reduce our fractions. I'm going to do the same here. I'm going to get x equals 6 over 9. Again, if I reduce it, I get x equals positive 2 over 3. And then that is my answer for that. Okay, let's do another one. Here we don't have a difference of perfect squares. The only thing we can factor out is a GCF. And a GCF is going to be 11. It's going to be x. So x minus 11 stays behind. So again, we have to factor out a GCF here. And then we can set both products to 0. X equals 0. And x minus 11 equals 0. Again, we have 1. This makes it one solution. Here, if I add the 11 to both sides, then I get x equals 11. Okay, so you have two solutions there. Okay. And so we have two solutions. Oops. Let me write that a little bit neater. Okay? So that's how you solve quadratic equations, is that you have to factor it, set both factors to 0, and then you'll get your solutions. Okay, thank you for watching.